Alright guys, so welcome back. In this video here, just continuing from chapter 5 lessons, we're going to start introducing the concept of factoring. So the first thing we look at is common factors, and then the second concept we're going to introduce in this lesson is factoring by grouping. Then in 5.4, we're going to learn how to factor trinomials. So before we get to factoring by grouping, or greatest common factor, we want to review a little bit regarding GCF, the greatest common factor, or just common factors here. Here's just some example I've already typed up and make it easier for me to run through the video. So in example 1 here, we have 4 different examples, discuss how to find the greatest common factor. Greatest common factor of algebraic expressions or terms. Right, so if we have 3n and n, if we have 3n and n, if we have 3n and 9, sorry, we're looking for what would be the common factor or the greatest common factor that divides into both 3n and 9. So notice that the 9 doesn't have a variable, so this GCF doesn't contain a variable. It's just going to be the coefficient or just a constant. So 3 divides 3 and then 3 divides 9, that is the biggest common factor in this case. So the GCF in this case is going to be 3, because we can say 3 is the biggest number factor that divides into both 3n and 9, right? So okay, next example, we have 10a to the 4th, 25a to the 3rd, and 15a. So in this case, 3 terms have a variable a. So with the variable a, we can say that, okay, all 3 terms have a common factor a, but then this third term only have just a to the first power. So we know that the GCF in this case will contain a variable a, but it's just going to be to the first power because it doesn't divide to the 4th or to the 3rd. This term here only have 1 power, so we can't use a to the 3rd, a to the 4th, because this term only have power of 1. Next, we look at the coefficients. So 10, 15, and 25. I'm going to say 5 would be the greatest common factor in this case because 5 divides to 10, 25, and 15. 10 doesn't divide to 25 or 15, so it has to be 5 in this case. So 5a is the greatest common factor in this case. Next example, we have 2 variables. So the 2 variables are x and y. Okay, and then we're going to pick out the lowest powers for those variables, because the lowest power will guarantee to divide all 3 terms. So we know that the GCF in this case will contain x and y, and let's see what will be the lowest power for x. So in this case, it's going to be 1, and the lowest power for y is going to be squared because all 3 terms have a square there. So we know the GCF containing the variable x and y, x to the first y squared. Let's look at the coefficient. We have 2, 6, and 2. So it looks like 2 is the greatest common factor in this case. So that is the GCF. Next, we have a little more complicated expressions. So these are the algebraic expression in factor form. And they're not just x and y. They are in the binomial form. So we're looking at, this first algebraic expression here. We have x minus 5 squared is the factor. Y plus 3 to the 3rd is a factor of this first expression here. And then it turns out that all 3 algebraic expressions contain, these factors: x minus 5, x minus 5, x minus 5, y plus 3, y plus 3. Now the question is, to what power these 3 algebraic expressions have these factors in common, right? So I'm going to say x minus 5 would be one of them, and then the y plus 3 would be the other factor. So all 3 terms have the lowest power. In this case, going to be 2. So that's going to be squared there. And then this is the lowest power, which is going to be 1. Okay. So those factors appear into all 3 algebraic expressions. Now let's look at the coefficient. We got 6 there, 2 there, 6 there. So 2 seems to be the greatest common factor in this case. Okay. This is going to help us with factoring by grouping quite a bit later on in this video here. So now we get to practice factoring out the greatest common factor with these polynomials. We have a binomial, we have a trinomial, we have some weird ones. So when we factor out the greatest common factor, it's kind of like find the greatest common factor of these terms and then kind of like working backwards from the distributive property. So we want to take these polynomial write it in factor form. So in this case, both 7 21 will have a common factor of 7. Since the leading term has a negative, we want to factor out the negative 7. So that becomes just x minus 3. All right. So, you know, if we multiply this out, we get this. So factoring kind of going backwards, rewrite it as a factor form or product of its factor, or in a way that we can distribute to get the original polynomial. Okay. Over here, we know that 3, 9, and 12 have a greatest common factor of 3, but then since the leading term has a negative, so we're going to factor out negative 3. And then all three terms have a as well, so we're going to take out a. Okay. So the first term, so when we do this here, if we take out a negative, if we take out a negative 3a, we also say, okay, well, what goes here, right? Negative 3a times what to give us negative 3a to the fourth, so it's going to be a to the third, right? And then in the middle terms, negative 3a times what to give us a 9a to the third, so it's going to be negative 3a squared, and then negative 3a multiplied by a positive 4 will give us a minus 12a. So that's how we figure out what goes, you know, in the other factor once we take out the GCF, right? I want to go over to part E here. So in this problem here, we have 6z times 5z plus 3, and then plus 5 times 5z plus 3. So by looking at these two terms here, this one and that one, the factors that have in common will be 5z plus 3, 5z plus 3. This is be a binomial common factor. Okay. Let me erase this. All right, so 5z plus 3, 5z plus 3. So that will be the GCF, and we're going to take out the GCF. Okay. So we're going to say, okay, the GCF is 5z plus 3, which will be the common factor for both terms. Okay, if we take that out, we're going to say, okay, well, 5z plus 3 times what will give us back this part here. So it's going to be 6z as a leftover factor plus 5 over here. Okay, so we should always check to see if you know, if our math works out, you know, correctly. We can just take this and multiply to that, which give us this first term, and take this, multiply to that, which give us the second term. Okay. We're going to need this part for factoring by grouping in the next couple example here. This example 3 here, we're going to see this later on. So I figure we include this in this lesson. This saying that suppose we have a baseball thrown upward with initial velocity of 64 feet per second. Its height is measured in feet, described by the function h of t equal to negative 16t squared plus 14t. The question asks for an equivalent expression for h of t by factoring out the common factor. So it's saying that take this h of t and rewrite this. Just rewrite an equivalent expression by using common factor. So a common factor in this case is negative 16 for the coefficient, and there's a t there. So if we factor out negative 16t, we're left with t right there, and then plus 4 right there. So h of t now become this equivalent fraction by using, just factoring out GCF. Okay. We'll come back to this example in the next couple lessons. So now we get into grouping. Okay, so sometimes a polynomial doesn't have a single GCF that divides into all the terms. We are forced to walk around that by breaking these polynomials by groups or pairs or by triples. I don't know, whatever works. So in the first example here, as you can see, phi x, phi y, ax, ay, this one doesn't have a single GCF. So this polynomial here does not have a GCF that divides into all the terms. Okay, so although phi divides into the first two terms, a divides into the next two terms, but there's not a single GCF that divides into all four terms. So what we do is we are forced factor out GCF by pair. So we can say, okay, well, I can group these two, and I can group that two, and I can take out the GCF from there, and hopefully I can go further from there. So if I group the first two terms, the GCF is going to be phi. So that becomes 5 times x plus 5 plus a is the GCF for the next two terms. So we can take out an a, and then we have x plus y, right? So now when we get to this step here, we notice that, hey, wait a minute, in this line, I notice that x plus y is the common factor of these two terms here. So I can take that out as a GCF, right? And then that leaves me 5 plus 8. So we say this now become GCF, right? So that's the answer. So although some polynomial doesn't have a single GCF that divides into all the terms, we can manipulate that and still rewrite in factor form by pairing these terms up, and hopefully it works out. It won't work out if you know that when we get to this step, these two factors are not the same, and we have to readjust or reordering or regrouping, right? Let's look at this one. Okay. Again, this one doesn't have a single GCF, so let's try and group this two and then that two and see if that will work. We got W comes out, so that W minus 5. We got 3 comes out, so W minus 5, and looks like we have a GCF right there. So now we can pull that out. W minus 5 is GCF. This has leftover W, and then over here just the 3. So there's our answer. Now it's written in factor form. I'm gonna go ahead and skip to part D here. So D is slightly tricky, right? So again, there's no single GCF. Suppose we don't know what's going on. We're just gonna go ahead and just group these two terms here and then group that two terms and see where is that gonna lead us. So actually that doesn't have any GCF, right? So maybe this is not the way to go. Maybe I should regroup this. So I should regroup the AX to AY. So let's do that. Okay, so I'm gonna regroup those two terms and then I'm gonna regroup those two terms. Okay, so if we group the AX and AY and then 3Y and 3X, let's see. We have an A as GCF, so that becomes X minus Y. And then over here we have a 3 as GCF, so that's give us Y minus X. So as I said earlier, you know if you're doing correctly if you get to this step and you say, okay, wait a minute, I got an X minus Y and I have Y minus X. Are those the same factors or the different? Does it matter here? It turns out they do matter. It's like I'm asking you, well, is 5 minus 3 the same thing as 3 minus 5? No, one is positive 2 and one is negative 2, so they're not the same thing. So subtraction is not commutative. So therefore, X minus Y and Y minus X is not the same thing. So how do we fix this here? So we say, okay, make a note, Y minus X is not equal to X minus Y. Okay, so how do we fix this here? Well, what we can do here is we can, so what if in this step here, okay, I'm going to factor out a negative 3 as GCF. So use GCF as negative 3. Okay, so if I factor out negative 3, I'm going to get a negative y here because negative 3 times negative y is positive 3y. And then I'm going to get a plus x over here because negative 3 times positive x is negative 3x. And then the next step, I just rewrite that as x minus y because negative y plus x is x minus y. So now we have common factor there and there, so we can take that out, x minus y, and then a minus 3 as our answer. Okay. So hopefully that will help you get started with the homework with GCF factoring and factoring by grouping.